Hi team, this is Chris Abraham from GOHmath. Today we're going to work on number 27 on the FTCE Elementary Practice Test. This is a great problem to review some core concepts in math, specifically involving geometric shapes. And the concept today is going to be nets. Usually when we think of nets, we think about a 2D object that can be folded into a 3D object. So here's how number 27 goes. It says, which of the following two-dimensional representations can be folded into a cube? So these are all, A, B, C, and D are all two-dimensional representations that if we folded them up, we're hoping to get a cube or a 3D object. That cube there is going to look like this. So we're going from 2D, right? 2D to 3D. When looking at this problem, it's a little tricky. Unless you've worked with net a lot, it's hard to sometimes match it up. I want to point out first what the correct answer is. A is the correct answer. A, if you cut along the lines here, along the edges, and you folded up A, all the faces would line up and all the edges would line up to form a cube. There would be no overlapping of faces and all the edges would be touching. So A is the correct answer. Now what's wrong with B? Well, B, if you cut along the edges and you folded it up, it would have one extra edge on this side. And that one extra edge would kind of flip over and double overlap and there would be a missing top piece. So B could be eliminated for that reason. C, well, if you look at C, after cutting it out, there would be a whole bunch of places it would overlap. So C wouldn't work. And D, what's the major problem with D? Well, a cube has how many faces? 6 faces. And D only has 5. So there's no way that D could fold up into a cube. All right, this is the core concept behind nets. Taking a two-dimensional object, using it to form a three-dimensional shape. You can have more advanced applications, like let's say if I had this net here. What is this a net of? Well, it's a two-dimensional representation that if I folded it up, could be used to form a three-dimensional object, like a cylinder. This net here is actually really helpful because it could help me find out, this is the 2D version to the 3D version. The 2D version could help me find the surface area of the cylinder. And there's all sorts of applications that you would do in order to find out the formula for the surface area cylinder. But where we start working with students when we start working about surface area is we start introducing nets as an option to figure out surface area. All right? I want to look at some other problems real quick on this. Here are some samples of nets. Half of these are nets and half of them are not. Can you figure out which ones are nets of cubes and which ones are not? Try it. Well, remember, you have to take that 2D object, you have to convert it into a 3D shape. None of the faces can overlap and the edges have to line up perfectly. Maybe you recognize that this one looks like your classic net of a cube. So that's right. And maybe you can visualize this one is actually correct as well. You're going to have to trust me on this one right here and this one right here. Now, if you're not 100%, you don't 100% agree with this or you don't quite see it, the only way to see is actually to get your hands a little dirty on this, which means go to Google, type in nets, and see if you can print off some sheets, cut them out, and see if they actually fold up to form a nice cube. That's helpful because the more practice you get with this, if you're ever given a problem like this, you'll be able to identify very quickly that these ones are nets, and maybe you'd remember these ones are nets too of cubes. Hi team, I want to encourage all teachers that need some extra help on the math to check out one of the GOHmath workshops. We're holding them in Massachusetts and in Florida to help teachers get ready for the teacher certification exams. Check it out. I'm sure you'll find it very helpful.